right, greetings everyone, and welcome to another great episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, we are continuing on with our Python programming series. Joining us back in the studio again today is our resident Python expert, that is Justin Dennison. Justin, welcome back to the show. How's it going today?
Going great today. I'm really excited to dive a little further into Python, see those new data structures that we need in order to really make something interesting happen. You know, these first little bit is, again, putting tools in our toolbox, but now we're getting closer to the end where we're going to have, you know, a pretty robust tool set that allows us to do some pretty interesting things. So I think today the best thing to do is immediately move to lists, because we just saw strings, and strings are kind of like a list of characters. You know, I have A, B, C, D, the ABC song, or if I ask you to spell your name, you list off a bunch of characters. But there is a little difference in lists. Lists are mutable or mutatable. I can change elements of a list. I can change the size of a list, you know, using direct access. Whereas I can't do that with a string. Strings are immutable. I can get a new copy with changes, but I can't change the original string. Also, lists can be a collection of all kinds of different things. I can put string, number, and then like an apple object, if I was able to make that in Python, all together in a list. So lists can present some interesting problems, but we're going to stay fairly uniform. I'm going to emphasize some best practices for when you start, when you're first learning lists, that will ease the problems that people typically run into.
Oh, that's very cool. Now, we were talking and you said that strings are like a list, but lists are different because of their mutability versus the immutability of an actual string. How can we see that in practicality? If we're looking at Python in the interface, how can we start working with lists?
So if we jump inside our Python shell, there we go. Sorry about that. And we actually just start up Python. So let's just have a quick, you know, the quick brown fox. So we now have a string that has several words in it. I can't change any of these. I can take slices, as we've seen, you know, take every other letter or every third letter. But actually there's a method on strings that allows me to split these, either give me every character separately, or I can give it a parameter that says split it on spaces or new lines or whatever it may be. So let's see what that looks like. And now I've actually split the string into individual words because I split it spaces. So now I have a list that represents the original string. However, unlike strings, I can say, all right, I want, instead of that lowercase t, that's, oops, typo, I want to make that uppercase. And now I can actually change that element. I haven't changed the string at that position, but I have assigned a new value to that position within the list. And let's say that I don't really like, this brown fox isn't really that quick. So the brown fox, I need to remove that element. I can actually say del for delete, and delete, and since we're in a zero-based array, right, it's just like strings. These collections, these sequences are all zero indexed. I want to delete quick, so I'm going to say 1 because 1 corresponds to the second element, and now we can see that I've actually removed that element. So that's really the key difference, other than the fact that, you know, I can do weird things like this, where I can wait for it. I can come here and just change this to like a number. And now I have a string, a number, and a string. And I would recommend strongly against this, mainly because it makes it a little more difficult to reason about. If I'm running through a list and doing these operations, I may forget that there may be numbers in there, especially if I've put them there. I would keep the data within a list very uniform to start with.
Now, what's cool about this is this does seem a lot like in Bash scripting. We have a for loop that is you have basically an array, which is kind of like this list. It seems a lot like it, where you say, here is a list of things that I want you to iterate through, and it'll go through that each one at a time. And once it reaches the end of that list, it ends. The loop will end. Can we do something similar like that with these lists?
We sure can. So, you talked about iterating through, going through one at a time in Bash scripting. I like to think of list as a sequence, and that's to reinforce something. The order is preserved, so whatever I put first, unless I make a change, like I want to change the first element, then that will always be the first element. So I get that predictability. But I think what you're really talking about is, hey, you had that for loop that iterated through every character of a string, but can you do that with a list? I don't know. Let's take what we know from the previous sessions and see if that applies with lists. So if I wanted to iterate, and let's just say I wanted to print out each element on a new line, I could say for the element in slist, I'm going to print the element, and I can in fact apply what I already know about strings to a list. And that's what I really like about Python. It provides this, this intuitive feel. I'm like, oh, okay, these kind of remind me of strings. I wonder if I can do some of the things that I have done with strings with lists. And we're starting to see, I think you're starting to pick up, this is pretty intuitive. Oh yeah, that probably works like that. You're making guesses that in fact are correct.
Well, it's cool. Anytime you make a program that's that intuitive, where you can actually just start to see, well, if I can do this, then maybe I can do that as well. It does give Python that level of usefulness for the person that's maybe uninitiated, right? They start to see things and patterns that are coming about, and that's what we like about it. And we're really, really thrilled actually to be able to work with you on this. Going back to the list, though, what else can we do with the list? What are some of the other characteristics of using lists that we need to be aware of?
So pretty much everything that we've seen in a string is applicable to a list, with additions to the fact that we can change elements. So if we look, I have this slist. I know that has 3 elements, but let's say that I have a list that I've read in from a file, or I've read in from a user input. I don't really know, I don't know how many elements are in there. Well, I can actually use the len function and find that, in fact, slist has 3 elements. So len works with strings exactly in the same way that it works with lists. And, it almost forces you to see these patterns that are sometimes not as evident in other programming languages. In addition to, what's kind of weird is, we know that multiply by a number in a string, well, that repeats. I wonder if that works with lists, because we've seen up until this point, they're pretty close, so maybe I'll just try it. And in fact, I get a new list that is, element 1, 2, 3, or 0, 1, 2, and then a repeat, and then a repeat again. So I have now effectively made a list 3 times as long with a repetition of the elements. And then, we didn't really see this in strings, but there is this new keyword in Python where I can just test, hey, is something in here? And it reads very simply. So I can say, okay, is the in slist, and it is in fact in slist. And what I like about that is I don't have to write a loop to go through and test. In C and Java and some of the other languages, this is actually kind of laborious, because I have to start at the beginning, go until I find it, and then return true if I do find it, or return false if I don't find it. Here I just go, hey, is that in that? And I'm like, yep. Or it'll go, no. For instance, if I change this to a lowercase letter, it says, no, that's not in there. So it's a very strict comparison. Uppercase counts differently. Numbers have to be very specific. Like 13 and 13.1 will not necessarily evaluate to the same thing. These are not the same, so it would return false in that case. So in there is great. But let's see, I'm going to create a new list just so we can look. So
Really quickly, with the be able to look inside of there and use that in and create the true or false value, can we use that like we use other Boolean values?
that is a great question. Yes, that's actually the entire purpose of it. You can say, if this one thing is in this list of other things, then I want to do something. Otherwise, don't do this. So let's say you have a series of commands or a series of words you're looking for or a series of numbers that you're trying to sift through. If you can say, if, I'm running through this stream or log files, if this is in this list that I've predefined, run this code, otherwise do something else. So it actually makes it very powerful, easy to kind of think about, reason about, and that's why I really love it.
Yeah, you're kind of creating your own Booleans that you can then therefore create blocks of code that will do stuff that is specific and unique to your needs, right?
Exactly, and it's very easy to read, way easier than some of the other ways that I've seen that implemented. But if we, there's some other methods on the list. Some of them are related to numbers. Some of them are related to anything that is comparable. We're slowly adding in our standard built-ins. If I say, hey, I want the maximum of list 2, it goes, oh, that's 4. So I don't have to write those loops that typically come up in other languages to go, is this the biggest one? Yeah, and then spit out the biggest one. I can also look at what is the minimum, and it'll spit those out also. So that's incredibly handy. There's a multitude of these that work for list, and we'll start to see some more of those as we use them a little more. Before we move on, though, and really utilize these, there's a couple other things we saw in strings that I wonder if they work in lists. So we saw that we can access elements, like list 2. That gives me the first element back. I can do the same thing and change it. So I've changed that list now. But there was this other weird syntax in strings where I could say, I want to start at 0 and go up to index 2, 2 not included, right? I'll go from 0, 1, but not 2. So 1 beyond where I want to stop. And that will actually give me a list, a slice. So this is called a slice, just like it is in strings. So I can quickly go, I want to chunk this up and do other stuff with it. But just like in strings, I can also say, I want to count by 2s. They're from 0 to the end and count by 2s. And I get every other element as we've seen in list 2. So 2, 3. And these are the same, so don't let that be confusing. It actually starts at 0, counts over 2, grabs this one, and then it goes, we're at the end. So the slicing syntax works just like it does in strings. So that's really handy. I don't have to remember multiple things. I can, more or less when I'm starting, I can treat these as the same thing with the idea that strings can't be changed in place, lists can be changed in place.
Cool. Now, if I'm recalling correctly, we also used start and stop as well with our strings. Maybe I'm confusing, but can we do that here as well?
Yeah, so I mean, we've indirectly seen the start and stop. Let's be a little more specific here. Let's look back at slist, and then, okay, so I have 0, 1, 2. The slice is that start and stop. So I want to start at 1 and go to 2, 2 not included. So I have a start and a stop, and that in fact returns that slice. Now in this case it's a slice of one thing. So let's put that, let's look at S. So S is the quick brown fox. Let's get something a little more interesting here. I'm going to redefine slist, and this is something that I haven't talked a great deal about in Python. I don't have to create new variable names. If I just want to repurpose those, I can. But be warned, sometimes this makes your programs hard to reason about because you're like, well, up here it was this thing, down here it was this other thing, down here it's a number, over here it's a list. This is something you can do in the terminal. I don't recommend doing it actually in a program. So instead of splitting on a space, I'm just going to split. I'm just going to blow apart, and notice it defaults to a space. There are ways that I can split those along the characters. So let's see here. I've got my S list back. So if I wanted to start at 1 and go to 3, now we can see a little more here. I get just quick and brown. I get that little chunk here. So in general, this is the start, this is the stop, and then this is also the step. Now, one final thing about accessing lists, either with start, stop, step, or just individual elements, I'm starting from the beginning and iterating through kind of behind the scenes to the end. I can start at the end and go backwards. I can say, I want from 0 to the end. If I leave this out, it automatically jumps to the end, but I want to go backwards. So now, what happened? That's interesting. That. Did I type something wrong? No. Oh, I went backwards from the end. Sorry, that was totally my fault. If you put a 0 there, it actually starts at the end and counts backwards, and you get 1. So you get some unpredictable behavior sometimes when you start going backwards. But here, if I step backwards by 1, I actually go fox, brown, quick, the. So that's a way I can reverse the order of lists. Huh. So very, very powerful, but when would we use these? Well, I think it's kind of interesting to see how would we use these in an actual program. So if we hop over to our text editor, notice I have my shebang already up and running. I got my main portion defined, and what do we have here? So let's just start with fave foods. And Daniel, what are some of your favorite foods?
I'm going to have to go with at least pizza and spaghetti.
Pizza, spaghetti, and let's add a third one in there, mangoes. I'm sure those things go well together.
No, I just pour mangoes all over the top of my spaghetti and pizza.
Yeah. So I think I get pizza, put spaghetti in it, roll it up, and then dip it in a mango salsa. It's glorious.
Beautiful treat.
Yeah. So that's my favorite foods. And then what are some, let's just look at some random words here. Let's just make words. The hammer, car, and pizza. And you'll notice that I've intentionally, within this list of words, this may be a list that I'm reading in from users, something of that nature. Okay, well, there's some shared there, but now I can use this to make decisions. So I could say for a word in words, and this is a common convention you will see in lists. Lists will be plural, whereas a single element would be, singular in nature. So for every word in words, I want to run through if word in fave foods, I'm just going to say, hey, that is a favorite of mine also. Otherwise, I do not like that. All right, so I have a list that I'm referencing. You ask about that membership, that in keyword, how would I use that? This creates a Boolean, whereas this actually allows me to iterate through. So I have this list that I'm comparing against, and I'm going to go through and look through these set of words. For every word in words, If the word is in favorite food, say that is also a favorite of mine. Otherwise, say I do not like that.
So it's comparing the two lists together. It's checking to see, well, I'm looking through this list, and while I'm doing that, I need to look through this other list as well. And if I find anything that's common, then I'm going to print a certain output. If not, I'm just going to print this other output.
Exactly. And again, this is kind of a hokey example, so we can reason about it. We'll actually take some user input and see how this would work interactively in just a moment. So if I run this in my terminal, I do not like that, I do not like that, I do not like that. That is a favorite of mine also. So if I hop back over into my text editor, it starts here. I don't like the to eat. I don't like hammers to eat either. And I don't like cars to eat, but I do like pizza.
The carbs are too high in saturated fats.
They
so
are.
stay away from those.
You got to be careful. Saturated fats, trans fatty acids.
Yeah.
Not to mention the tires are actually really chewy.
Yeah.
I don't know. So this is pretty interesting. But how would we use this to interact with our users? Let's say I want to make a program that takes input and provides some kind of statistics to my users, or actually goes and searches, their favorite foods, or something you're looking through for a log file, or searching your computer for, or maybe even the internet. Now, to keep down on the amount of input, I'm actually going to just highlight all of this, and in my text editor, I can hold Command and slash, the one next to the question mark, and it'll actually comment all of the lines out for me at once, which is good if I want to reference this later, to see how things are working, but I don't actually want it to run. So within a list, we have a couple other methods that would make this useful. I'm going to say this is my user input list, and I'm just going to make an empty list. And I'm going to say while true, then user input equals raw input. What are some numbers to sum up, right? Again, kind of hokey, but how do we interact with these users? Press Q to quit. Okay, so I'm going to address this. There's a couple of things. The only time that I need to treat it as a letter is when they type Q. Otherwise, I'm assuming they're typing numbers. So if user input equals Q, then I want to break. Otherwise, and I just want to, grab this all these numbers. I'm writing a calculator for someone, very simple calculator, or maybe a teacher needs to quickly sum up all of their students' grades. They can just type these in. I'm going to put those in the list, but I also have made the assumption that these are going to be numbers, and in particular, integers. Let's say this teacher always gives whole number grades, which is not unreasonable. So I can say user input, and I want to make sure if it's not a Q, then I want to say, okay, change that to an integer, just like we had before, and then user input list. And then there's another one that we can use called append, and what that'll do is actually push those onto the end of that list. So append user input.
So since we have an empty list, there's no data in it whatsoever. As the user inputs data, it starts adding it to our list and therefore giving us something to actually work with.
Exactly. So now this is happening as long as my user's typing numbers and hasn't typed the number Q, or the letter Q. And I've made some pretty naive assertions, right, that they're not going to type things they're not allowed to. But if you're the one using this program, you know the parameters. And there's kind of an unspoken contract between users and how these programs work. That, hey, I'll hold up my end of the deal if you hold up your end of the deal. So we've all had that blue screen of death, or you're like, huh, that's interesting. That broke hard. So once this loop, the user quits, they've added all of these numbers. I just want to tell them what the sum is. So I'm going to say output is a string that says your sum is. I'm going to use that formatted string and just say format. And when I had a list of numbers, we saw min max. I could make another for loop that adds up all of these things, but I can also just say find the sum of the user input list. So sum, min, max, we have some, again, I don't even have, I'm wondering what that's doing. Oh, it's probably finding the sum of all the things in that list, and then I'm just going to print the output. So, again, kind of hokey, but we'll notice this is increased in complexity. This is the main portion of our script or our program here. I've started with an empty list. I've populated that list through user interactions and only done so when the interaction has not been a queue. And then when they finally say, hey, I'm done, then I'm going to output the sum to the screen. So what are some numbers? 1, 3, and I got some weird output here. This is an example of a runtime error. I forgot to put a space at the end. Easy fix. It's not really going to affect how my program works, but it is a little annoying. What's your favorite number, Daniel?
My favorite number is a Googleplex. No.
All right, Daniel.
Let's keep it realistic.
Yeah, let's keep it realistic.
Let's go with 9 is a good number.
9. And then let's go ahead and quit. Your sum is 23, and 1 plus 3 plus 7 plus 3 plus 9 is 23.
Good job with the adding in the head there.
Yeah, so that's one way that we can interact with users, populate a list, and then make a bunch of decisions. Now, how would I actually use this? And we'll see this shortly. Is I may take a lot of commands from users, or just like tasks that I need to do, and then when I've populated that list of tasks, I just run through, like go search out all of your trash directories, go clean them, and then quit. So trash, clean, quit, and that would be a list of tasks, and I would have a bunch of if statements that did something based on those input parameters.
Yeah, I can see how that could simply be done. You're just basically building a list of maybe some directories that you have common areas in which you throw things away, you use them, then you want them to be cleaned on a daily basis or something of that nature. Create that list through user interaction, ask you what directories do you want me to clean out, give it that information, and it creates the list, and from that list, you start running your loops, start running your decisional statements to go into them, find out if there's anything inside of them. If there is, delete it, and then get out and break the session. It's a very, very helpful little handy item that we got there in Python.
Yeah, and I personally, I don't know. You're the Bash expert. Is that hard to do in Bash?
Is that hard to do in Bash? It might be around equivalence, just because Bash works so integrally with the operating system itself, so you can take advantage of any of the commands that are built into the system. So I might be able to just write a really quick delete script that does that. But if I want to get that user interaction, I want the user to tell me, okay, I don't know what directories you want me to delete any information out of. I need you to tell me what they are. It probably would be a little more difficult to work that out, just because I couldn't create a list like what you have. Mm-hmm. It would be more difficult to do that.
So that is the power. So there's some trade-offs, right? And I ask you about Bash because I look at this as a possible replacement for Bash, and as we've seen, Python's pretty much everywhere. So there are trade-offs, either place. But you said something that was interesting. That's almost like foreshadowing. I have access to all these system commands that are so integrated. I do have a surprise for you in the future, Daniel. But I think that's a good start on list, though.
Well, excellent. It definitely is like you said, a great start on list, actually, because we have the foundation, we see what we can do with it, and we've barely even scratched the surface on it, to be honest with you. I'm sure it has a lot more. I mean, we've seen all those modules and things that you have available to them, so as you start playing with it, don't be afraid to jump in there and see what else you can do with it. But for right now, you should have a great like I said, it's foundation to build upon as we continue on with our series. Justin, is there anything else about lists that we need to cover for this episode?
Not at this moment. They'll keep cropping up. They're kind of like the core data structure that everything else behaves like, or has some way to interact with in Python. So I think we're good for now.
All right. Well, thank you so much for explaining lists to us. You did a great job demonstrating that. Thank you guys for watching. We're going to go ahead and sign off for IT Pro TV. I've been your host, Daniel Lowry.
And I'm Justin Dennison.
We'll see you next time.